talk about a logical approach to cosmology.
Exactly.
Right, okay. Well, I don't know any more than that, so you might sort of stop. Thank you.
How much time do I have roughly?
Well, we have,
20 minutes?
including, yeah, if you can present for 20, but then we can have discussion.
Yeah, okay, so I think it would be best for us to work that way. So I'll ask you 6 questions, and I actually plan to leave them on the board, so you can kind of think about them in the process, and you can give them an answer of your own, and after that I'll try to answer them from my point of view, and we'll see if we agree or not, and hopefully there will be some discussion afterwards. Okay, so when we're talking about cosmology, one of the, which space would I need? Well, let's try that much. So the first question I would ask to you is, how many universes are there?
None.
One. It's in the name. It's in the name.
Well, not none.
Okay, that's the first question. The second question would be, let me just consult my notes a little bit. Okay, is the universe, or universes, finite in space?
No.
Sorry.
Just put
These are great questions. Finite in space.
In space, yeah.
Is that not tautological?
I don't know. We'll see. In space. So the third question that I would ask would be, is it finite in time? Well, I'll just denote the universe like that, for sure. The fourth question I would ask would be, does the universe have a definite size?
By size, you mean mass or what?
No, spatial size.
Isn't that the first,
Second one.
or the second question? No, but, sorry, isn't that
Well,
question two?
some of them are connected indeed. Well, let's just... So the fifth question I would ask would be, can the universe expand? Obviously connected to the previous one. And the sixth question would be, does the universe has a definite mass, charge, or some other properties like that? Or have? I don't know. My English isn't very good. Charge. Etc.
So how about, is it a closed system? Could that be a
Well,
second?
I wasn't. I did not ask that question. Although it might, you might say that it's implied in some
Well,
of
that's
them.
in number 5, isn't it?
Okay, so I'll try to answer those questions from, again, my point of view. And some of the principles I would utilize here would be a philosophy of positivism. I'll describe that in a couple of sentences a little bit later. The principle of causality, which I can also describe to you in more detail, but I think it's self-evident.
Yeah,
Like, actually, a lot of things I would be talking about, you can explicate logically, but that would just take some time, you know, so I'm simplifying a lot.
Yeah, perhaps just to define the meaning of the word universe, it means turning as one, universe.
Well, okay. I'll give my definition of the universe.
The Oxford English Dictionary will not define.
I just like explicitly state the principles I use so that, you know, if there would be any questions about that. And the third principle is I would use the Cartesian approach to what a physical body is. I would basically consider a physical body anything that has size, basically. Whereas, you know, there's like Newtonian approach where a physical body can have no size also. You know, a mathematical dot might be a physical body according to Newton, but according to Descartes, it cannot be. But those are just the principles. So the philosophy of positivism, it appeared in the 40s of 19th century, so 1840 something, and it was sort of like a response to Hegelian philosophy, which was really popular at that time, you know, German classical philosophy, where people invented, you know, all kinds of stuff, all kinds of metaphysical objects, like the world spirit of Hegel, like all kinds of stuff. So positivists said, you know, in science we better not invent stuff that we don't observe. So that was the main point. Like we should only work in science with objects that we can interact with or observe, which is the same thing. Like observation is a particular case of interaction. Okay, so this is what I'm going to use. So I'm going to give the first definition, which would be my definition of the universe according to those principles. So we'll say definition 1. The universe is, and again, I'm going to be doing that in plain English, let's say. I can use like quantors, you know, like logical, this bird speech, but I would use just regular English. So it's all the stuff, sounds pretty simple, right? It's all the stuff that we can interact with in any possible manner.
Or in
got rid of
that.
97% of the
You mean receiving light from a billion years, light years away that's interaction.
Yeah, yeah, I consider that as an interaction. Because it influences us in some way, right? Okay, so that would be my definition for the universe. So, I'm going to try to answer those questions following the logic of the proof by contradiction, basically, you know, reductio ad impossibilite, as it is called. So, let us assume, like, let's start with the first question. Let us assume that there are many universes, like there are parallel universes, etc. What would happen in this case is, if we can interact with those universes in some way, it means that by definition 1, they would be part of our universe because we can interact with them. But if we cannot interact with them, according to this principle of positivism that I've stated, we can just forget about them. Since we cannot interact with them, what does it matter, you know? They don't exist for us. So that would be my question for my answer to the first question. We only have one universe according to this definition, all right? Hopefully that was clear enough. I'll kind of summarize it all in the end, hopefully. So, the second question. Oh, damn, it doesn't work. Okay. Okay, forget it.
We can sell the blackboard like they did for Einstein.
I would just need some space later, that's what I'm concerned with. Alright, so let's just say it's the second question right now. The second question is the universe finite in size? And here I would have to give two more definitions, unfortunately. Perhaps, so. Oh, that's great. Thank you.
Oh, look, matter. How amazing is that? Okay, I've still got some paper left on here.
So, I will give you a definition. Damn, now I've screwed the marker too. Can you see that? No. Okay. So the definition 2, I'm introducing that to answer the second question, would be, is that an object is finite if it has a border,
I don't know.
okay, it seems kind of self-evident. If the object is finite in space, then it should have some border, right? And I will give a definition of a border also.
That's
I'm sure it's enough space.
Mechanics.
Yeah. Unfortunately, the board is very finite in space. So we would say that the border